Okay, 1 minute to go. Dennis, may I start? Okay.
Good.
Okay. Good morning, good afternoon all. I am Antonella Toffetti and I'm really very happy to give you my and the executive committee members who are welcome to this Human Factors and Ergonomic Society Europe Chapter Spring event. And this is really a great event, a discussion with Professor Don Norman. In fact, due to the pandemic period restrictions, we had to postpone our usual autumn annual conference to April 2022. Then we thought to some online events, and immediately it came to our mind to invite Professor Norman, and he very kindly accepted. So thank you very much, Don. We really appreciate it. Before starting, just a brief, a short introduction to Professor Don Norman. He is founding director emeritus of the Design Lab at the University of California, San Diego. He is co-founder emeritus of the Nielsen Norman Group, former vice president of Apple, and executive at Hewlett Packard. He is Distinguished Professor Emeritus at the University of California, San Diego, where he served as chair of the psychology department and founder and chair of the cognitive science department. At Northwestern University, he is the Britt Professor of Design Emeritus. Don Norman is the expert on human-centered design. Business Week has listed him as one of the world's 27 most influential designers. He is a fellow of the Human Factors and Ergonomic Society and recipient of the Human Factors and Ergonomic Society's Arnold Small President's Distinguished Service Award. He has published 20 books translated into 20 languages, including Emotional Design and Design on Everyday Things. And now he is with us. It is a big honor and pleasure for all of us to have the chance not only to listen to you, Don, but also to interact with you on topics suggested directly from our attendees. Thank you again, Don, and we are looking forward to be inspired by your thoughts.
Thank you.
Before starting the discussion, just a thanks to our co-director, Dennis Coelho, for organizing the Zoom connection. And now I leave the microphone to Stephen Fairclough and Dick Dewar, Secretary and past Secretary of the Human Factors and Ergonomic Society Europe Chapter, who will moderate this conversation with Professor Norman. Thanks, Steve and Dick. Please, the floor is yours.
Thank you, Antonella. Good afternoon, everybody. I'm very much looking forward to this event and this discussion today. Just for your context, we have pre-selected a number of questions and questioners. So I'm afraid you won't be able to put any live questions on the chat for Professor Norman today, but we hope that you'll enjoy the discussion and find the questions stimulating. So with all that said, I'd like to invite our first questioner, and that is Andrew Ritz. Andrew, are you there?
I'm afraid he's not, Stephen.
Oh dear, okay.
I emailed in the meantime, but he's not. So let's improvise. That's okay. What we are good at, right?
Well, shall I ask his question?
But maybe Chris Porter's question has some overlap, and Chris is here. Maybe Chris can ask his question.
Yes, okay. Let's go straight to Chris then.
Actually, why don't we get rid of my picture so We don't need to see the poster anymore. Thank you.
Okay. Chris,
Okay.
are you there?
Yes, I am. Yes, I am. Hi.
Please,
Thank you. Thank you for having me, and thank you for this opportunity. So basically, my job is in, so I'm in academia, and I have an interaction design class and an HCI class. And my experience with undergraduate students is that I always see that they have a basic misunderstanding of UX, right? They are understandably lost at first when they encounter sort of the various terms found in academic research: HCI, usability, UX, LX, human factors, ergonomics, user-centered design, and all of these terms. I try to start off with a slide trying to demystifying all of that, putting things in some form of context. But based on your experience, how would you go about demystifying all of this to a class of undergraduate students or software development students? More than that, I try to do that, but I'm not sure my answer always helps that much, really. Thank you. Thank you, Darren.
Thanks, Chris. Basically, the terms are a mess. Because they each one of them had some historical origin, and there are multiple societies that are all involved. There's a computer scientist, there's a psychologist, there's the human factors experts, there's the design community. And I think we should ignore it. That the real issue is, what are we trying to accomplish? And we are trying to build systems that really meet the needs of the people for whom we are building them. And in doing this, there are a number of different requirements. And some of the terms originated originally with these in mind. Let me give an example of, there's lots of examples. When I first started in this business, I published a book in 1986, I think it was, called User-Centered System Design, which are the initials UCSD, which is my university, University of California, San Diego. But it was one of the very first usage of the term user-centered. And we really were trying to say, very few people at that point actually focused on the people they were designing for, they were building for. It was all done by engineers who said, if you can't use it, well, you have no business using it. And in the healthcare, there's huge numbers of medical errors that are blamed on the nurses, on the physicians, and it's almost always just bad design. It's something that the human factors community is very well aware of. But so user-centered was an attempt to focus on the people. And later on, I said, I don't like using the word user. I don't call you a user, I call you a person. And so I should have said we could call it now people-centered design, but we decided to call it human-centered design. But there's no difference between what I called user-centered design and people and human-centered design. The difference is the one word in the title. But if you look at Wikipedia, for example, where you look up human-centered design, the first sentence says, do not confuse this with user-centered design. What? So first of all, those are the same. Second of all, the term user experience. When I retired from the university, I retired in 1993. That was my first of 5 retirements. And I went to Apple and became a vice president. And we started, I thought that the ability to use Apple computers was decreasing over time. And so I established what I called the User Experience Architect's Office. And I called myself the User Experience Architect of Apple. And by user experience, I meant everything. So the user experience of this podcast is, how did you hear about it? How did you decide you wanted to sign up? How did you remember that you should actually attend? How did you get here on time? And then what are you seeing now? What's on the screen? Is something of interest to you? Will you tell other people about it? In other words, the experience is a system, everything. And today the term user experience is widely used, and basically I found somebody who says I'm a user experience person. I say, what do you do? And they say, I design websites. No, that's not what we had in mind. So the terms get distorted, but here's what really matters. We are trying to design things that work, that are useful. You don't feel frustrated using it. You should feel good about using it. And if it's a website, yes, but the whole point of the website is to answer questions, give you information, or in this case, allow you to follow what I'm saying. And if it's a medical device, it has to be something that's usable and gives the appropriate information. And it's easy to design something that works well if everything works. But almost always something goes wrong. And in the medical profession, nurses, they are interrupted, what? Every 15 seconds, every minute? They are continually interrupted. And when you're trying to program a medical device or set it up or work with enter information into a form and you're interrupted, what happens when you come back? And a huge number of the medical errors that we have are because the equipment was not designed if you come back. You don't remember where you were, so you duplicate something or you skip something. Or what happens if you're typing and you make a typing error and you notice it immediately, but how do you correct it? I've seen cases where nurses could not figure out how to correct it, and the only thing they could think of doing was pull the plug out of the equipment and plug it in, hoping that would reset everything. But sometimes the equipment is too smart. It remembers the state it was in, so it actually doesn't correct the error. And actually, this has led to deaths with huge overdoses. So that's what I care about. I care about designing equipment that works and that is enjoyable to use. And but all the different words that people, let's just assume that everybody means well and they're using different words to describe their approach, and tell your students not to worry about it.
I will. Thank you so much, Dan.
Okay, thanks so much. We move on to Norway, to Stig Johnson, who's going to ask something about accidents. I think, Stig, you are here. I can see your picture.
Yes,
okay.
I'm here.
If you have a
camera,
you can hear me? If you have a camera, it's nice to switch it on.
The connection is poor, so I turned off the camera because sorry about that.
We can hear you. So
yeah, great.
Please ask your question.
Well, I'm a safety scientist at SINTEF in Norway, and I'm also teaching at the Norwegian University of Technology and Science. And there's one interesting thing that I'm very interested that I've been working with lately. It's try to see if there are any systematic research about accident that is caused by poor design. Because I found a couple of articles in Safety Science saying that around 50% of all accidents is due to poor design. And I strongly agree about that. But has there been done any more systematic research related to this area? And how should this be investigated when you are looking at an accident?
That's a very important question. And it's there has been remarkably little evidence. I believe that the number you quoted, that, well, first of all, human error, medical error, as it's sometimes called, is sometimes called the second largest cause of death in medical care. And I actually suspect it's not the second largest, it's the first largest, because it's not well diagnosed, not well reported. And the notion that 50% are caused by bad design, I don't agree. I think that number is too small. I would say most of it is caused by bad design. I could even try to say all of it is caused by bad design. I think,
I agree.
I think if you said all, that would be more accurate than saying 50. because the real number might be 99%. The problem is it's all too easy to dismiss this. When something happens and goes wrong, what you do is you tend to look at what the last thing that was done was, and it's usually somebody entered something wrong or somebody did something wrong, and so you blame it on human error. You say, see, human error again. And so you want to do is you train and blame. I blame the person, and they should be retrained or maybe fired or punished. But that isn't enough. You can't say it's done by human error. Yes, it was a human error, absolutely. But you have to ask the next question. Why was there an error? And the error, usually when you actually trace it down as well, because it was confusing design, or maybe an incompatible design with other equipment. One of the problems we have is that the different manufacturers all use different ways of doing things. And it might be that if you actually looked at each piece of equipment in isolation, it was pretty good, pretty well designed. I can understand it, I can learn it, I can use it. And I look at this other one, it does the same thing. And it's pretty good, I can learn it, I can use it and do things. But if you put them side by side, they're incompatible. They do things in completely different ways. And when you are the nurse attending in a big ward, you might have one brand here and one brand there and a different brand here, and suddenly there's a new brand you've never seen before. And so in this case, it isn't the design of the individual equipment that's the problem, but it's still a design error. It's incompatibility among the different manufacturers. It's as if that when you got into your automobile, the accelerator pedal in some cars is on the right, and in some cars it's on the left, and in some cars it's a hand control. And the brake is in different locations. And the answer to this issue is we must have standardization. And companies hate standardization. In fact, there's a rule that says the leading company is against standardization because they want everybody to buy their equipment, and they want to say that their equipment is the best, and they don't want it to look something like the other equipment. All the other companies, the ones that are not the leaders, they're the ones who want standardization because they want to have something that is just as good as the leader, say. But unless we standardize on the fundamentals, we're not going to get rid of all of the errors. But the other problem is that people often blame themselves. The standard example I use is a simple kitchen stove. Now, kitchen stoves usually have 4 burners arranged in a rectangle and usually have 6 controls arranged usually in a straight line, horizontal or vertical. And this has been a classic human factors problem since, I don't know, the 1930s, 1940s, but we still have the problem. And so many people turn on the wrong burner or turn off the wrong burner. And it can cause accidents, it can cause fires, it can cause damage. But when you do that, we don't blame, almost nobody blames the design of the stove. They say, oh, I'm so stupid, it was my fault. Well, blaming yourself when it's actually poor design, no. But again, that makes it difficult to collect the statistics. Now, in the United States, the National Academy of Medicine has done a number of different studies of these issues of medical errors. And they just issued a new report. I was, when you told me the question, I was ready to turn to my computer here and do a search, but I really shouldn't do that while giving a talk. But there are some, I do remember there was a recent study, which I haven't had a chance to read yet, about these kinds of issues. I don't know if they answer the question that you asked, though.
Okay, but then it's an interesting question then.
It is. The error in general is a very difficult thing to look at because it's easy to find somebody to blame. When there's an airplane crash, for example, in the newspapers, almost always in the beginning, you'll be told it's human error and et cetera. And the pilot died, so we can't check or whatever. But what happens is, again, I'll talk about the United States, which I know better. We have something called the National Transportation Safety Bureau, Safety Commission, which examines in great detail every single aviation and automobile and other crashes where, significant accidents, significant deaths. And every country has this. And they often take 2 years to come up with a conclusion. And they are very good. They have human factors experts on their team, a large number of them. And usually a human factors expert is a member of the major board. And what they almost always say is there are 6 or 7 contributing factors to this accident. And if any one of them would not have happened, we wouldn't have had the accident. So in other words, you can't say it was human error or that it was even a failure of this or that or this, because no, it could have been any of those and they all contributed. So that's really the golden standard for me. And I've been trying to convince the medical profession that they should use a very similar procedure. But in the medical profession, in aviation, pilots now are encouraged to report their errors, because they know that if they report their errors, and there's a way they can do this so they remain anonymous. But by publishing the errors that pilots have made, I accidentally took the wrong taxiway. Then what happens is we can look at those and back off and say, well, those taxiways in general are not very well located, are not very well named and signed, and there's actually not that hard to make an error here. And so we can fix that before any damage happens. Physicians don't do that. Physicians refuse to admit that they've made an error. And that makes it difficult for us to solve the problem. And we have to change the culture where actually the most senior people ought to state, here's the things I did wrong. Now, there are some places where this happens, and so it is possible, but the profession doesn't help us.
I strongly agree with you that the aviation has the golden standard. So I've used culture and approaches from aviation. And lately I've been working with the Petroleum Safety Authority in Norway and with the Norwegian Navy, looking at some large ship disasters. And we find out that in both instances, there has been very poor design. However, it's very difficult to make a change of the mindset, going from looking at what actually happened to going back some steps and say that, okay, here it is poor design, because then you have to have some people understanding what design is, and you have to have people that actually understand human factors. So it's a little bit challenging, but I think I will try to continue my crusade.
Well, one of the most frustrating experiences I ever had is I was called in as a consultant to a power company, an electric power company. And the person who called me in said, look, we kill our employees they're working in dangerous situations with very high voltage, and we've been electrocuted a couple every year. And I thought I was the first person called in. I discovered later, no, all sorts of other experts have been called in. But what I did is I went around and I spent several weeks with them. I watched them repair. It's really interesting to watch how they fix high voltage transmission lines, really high voltage. They don't want to turn off the power. That would turn off the power for 100,000 people or something. So what they do is they fly a helicopter over the transmission tower, and they lower a person with a winch down to the transmission tower. And then the person works on it, because you can touch a high voltage line. It's perfectly safe. Birds sit on it with no problem, as long as you don't touch anything else. And they do all sorts of things. But what I discovered is when I went into some of the plants, there'd be a big door, for example, that said, keep this door closed. And it was open, wide open. And I said, well, what about that? And they'd say, oh, that's an old sign. It's not necessary anymore. Then why do you still have the sign there? And there were all sorts of problems like that. On top of that, one of my favorite accidents that they had was they had one of their most senior experienced person, and they had installed a new transformer in a location, and they forgot to record the serial number of the transformer. So they sent this person back to go, would you please just go look at the serial number and write it down. Well, he got there and he couldn't see the serial number. It was dark and it was in a funny location. He took out his flashlight and that didn't help. And he tried all sorts of things and he was about to give up when he said, oh, I know what, I'll take a picture of it. So he went back and he got his camera and he tried to put his camera in and take a picture. And that's the last he remembers. He woke up later in the hospital and he doesn't remember what really happened. Well, what really happened was he got too close to the high voltage lead, and you can't get any closer than a meter for safety. In this particular case, in fact, there's a big sign saying, get closer than to a meter to this item. And he knew that, so he blamed himself. And I said, look, if somebody is so busy down there trying to do their job, to read the serial number, and therefore their head accidentally gets too close to the high voltage lead, don't blame the person. Why couldn't, and I showed them how you could make a cardboard shield, and that before the person did the work, you would put this shield up and it would prevent you from going too close. And they said, oh, well, gee. Nothing ever happened. My reports were ignored. They were read by the person I liked who invited me. And then I discovered that they had a number of other really good experts, people I knew, had come in before me and said the same thing. And they ignored them too. So I don't know what you do here. I even talked to their top management and I told them the stove burner story. And do you all understand, have any of you made that error? Well, yes, I did. Well, you understand what I'm trying to say? Oh, yeah, we understand. But they didn't change anything. That is really frustrating. I don't know. And I checked back a couple of months ago. I wrote back to my friend and said, what changes have been made? And he said, nothing, we're still killing our own employees. This is a bad story to tell you because it's not going to reassure you, is it?
Well, it says that you have to try as hard as possible for a long time, maybe.
It's so easy to blame somebody. And on top of that, it's so part of us, we apologize. Oh, I'm really sorry. I got too close to the high voltage terminal. Oh, I'm really sorry. I flipped the wrong switch. Oh, I'm really sorry. I didn't see that the switch was on, the switch behind the safety tag that was blocking my view of the switch. I didn't see that it was on, and therefore I worked inappropriately. You blame yourself, and that we have to change that model. And I've tried. I wrote a book, The Design of Everyday Things, and one of the important messages of the book is it's not your fault, it's bad design.
Yes, I've seen the book. I'm trying to give it to people that is working with engineering, but in some way they don't learn enough about human factors and design. So that is some cultural thing that's hindering that people don't learn.
The problem is they don't understand the human factor profession. They just assume it's all common sense. And once they think it's common sense, they don't know what you're really talking about. Why are you making it more complex? But we're killing people. Now, the medical profession is concerned about this. And so at least, again, in the United States, I assume in the EU as well, we've, the National Academy of Medicine has done a number of studies, and they have many good commissions. And there are many physicians and surgeons and anesthesiologists who are trained in human factors. So human factors is a standard training for many of these people.
Okay, thank you. I'll try to argue more for human factors training in the engineering profession. Thank you very much.
Thank you, Stig. Thank you. Chris, I can see you've got your hand up, but I'd just like Go on, ask your question. We'll do that now. Yeah, go ahead.
So thank you, Stephen. So would it make more sense to teach human factors as opposed to HCI and user experience and UCD and all of that? So back to my my original question, literally teach basic concepts around affordances, basic concepts around what is not common sense for engineers and what is common sense for people, and vice versa, perhaps. So I don't think human factors is given as much importance in the software engineering side of things, perhaps. Well, then what is your view on that?
No, I don't agree completely. First, but the last one, first of all, human factors, believe me, is extremely important in software. How many errors have you made in software in using systems?
Yeah.
But second, I think that the artificial disciplines, because all disciplines are artificial, they're made up, whatever, historically, we focus on this. I think that the division between, say, design and engineering and programming and human factors is wrong. Because there's a problem. Most human factors people are really good at finding deficiencies. But that's only part of the problem. The other part is designing something that does not have those deficiencies. And most human factors professionals are not good at design, don't understand the issues of design. And so that's a major problem. And I think that a lot of the difficulties, because what it ends up being is that many human factors professionals are called in afterwards. I remember I was asked to give a talk to the human factors group in the United States at the National Academies, and they've named themselves. They tried to say human factors nobody understands. So our name is now Human System Integration. It's a nice name. But I said, okay, you asked me to give a talk to you, and I would love to see some case histories that I can talk about of successes of human factors. And so they well, we just wrote a book about that, and they sent me the book. And I read the book, and I came back and I said, no, those are not success stories. What those stories were, in every case, was there was this major incident, and we sent in the human factors people of the community, and they said, this is wrong, and this is wrong, and this is wrong. And I said, that's like asking for success in preventing fires. And what you do is you send me the report to the fire department, which is really good at putting them out. But that's not the same as preventing them in the first place. And so the human factors community want to be more involved in preventing this, which means you want to be more involved in the design profession. And by the way, I've given the same talk to the design profession, in which I said, you guys ought to know more about human factors, because the two go together. And if you can't, and here's the other thing I tell people. When I was an executive at a major software company, as you know, it's Apple, but I've been working in lots of other companies too. I didn't want people to come and tell me the problems. And it isn't because I didn't want to learn about problems. I didn't want problems, and I didn't want to hide from them. But what I wanted was them to come to me with the solutions. So telling me that there's a big problem, that doesn't help. I need to know what the solutions are. And too much of the human factors community is finding the problems, as opposed to redesigning the equipment or working with the companies to do the equipment appropriately. And that's I think the problem. So the reason I say no, we shouldn't make, to your question about where do we teach human factors, I think it should be taught everywhere. It's too important to be left. Here's a problem with the human factors community, and of many communities. And mind you, look, I'm a fellow of the Human Factors Association. I've been doing human factors for most of my career. And I I'm a fan of human factors, but look at this conference. This is a conference on healthcare, and who is coming to the conference? It's human factor professionals. And so what happens is we are talking to ourselves, and we're complaining to ourselves about the problems that we face in our work. But we should really be giving these talks to the medical profession. And we should be giving these talks to the executives in the medical profession, because those are the ones that actually spend the money to buy the equipment that leads to error. We have to get outside our own profession. And we, moreover, have to make sure we get it to the right people. One of the problems in purchase of equipment, why do we purchase the wrong equipment that's badly designed? Well, because often the purchase people are looking at the price, or they're looking at a list of features. They don't have human factors training on how to evaluate the equipment that they're buying. They ought to hear the lessons, or they ought to be part of this message too. Whereas the people who often really specify what is going to be required are the physicians. And guess what? The physicians almost never use the things that they specify. It's used by the technicians, the technical people, and the nurses. And so we have to work with them too. And we have to, in fact, stop this process that the senior person is the one who orders the equipment and specifies what is needed when they never actually have done it. Or maybe they did it 10 years ago before they got promoted. So it's a complex system. And the only way you can deal with complex systems is by recognizing the system and making sure you address all of the critical components.
Okay. Thank you, Chris, for your question. Thanks, Don. That was a very interesting answer. Our next question is from Philip Tretton. Philip, I can see you're there.
I'm here.
Good afternoon. Go ahead and ask your question.
Yes, good afternoon. Thank you for giving me the opportunity. I met you, Don, in 2010 at Stanford. You gave me a copy of your book, Complexity, a signed copy. It was kind of neat to talk to you there. I appreciate it. That's something that I've spread to other people, that you're very down to earth, easy to talk to and friendly. And that's good. My question is based on my research right now, and I'm looking into decision making for maintenance. I've worked with the Swedish Air Force, looked at maintenance tasks and stuff like that. But what it is do you see artificial intelligence technologies surpassing human problem-solving capabilities in the near future?
Yes and no. Most technology does something better than we could do.
Mm-hmm.
It's a tractor can pull heavier weights than we can pull, and so on and so forth. And so I think AI is going to be the same way. It'll do some tasks better. And a good example, but first of all, AI is a complex field, and today it is misunderstood because of the great success of machine learning and neural networks. We think that's what AI is. No, that's only a small component.
Mm-hmm.
And one of the problems with machine learning and neural networks, say take the advances in deep learning, is that it's a pattern recognition device. It can recognize things, but it has no understanding whatsoever. And in fact, it can't recognize things from very unusual angles, although that's starting to change. So it's very limited in what it does. And it can make errors. Because the other problem with machine learning, as you probably all know just by reading the newspapers, is, well, how does it learn? Well, you give it lots of examples, but the examples are often biased. And so you say, oh, it's better than humans, it isn't biased. Well, but it learns from the examples that have already been labeled by humans subject to human biases. So it's learning badly. But let me give you a more positive example. Because it is a good pattern recognition, one of the most important successes already is in a field like radiology, where radiologists sit in front of computer screens all day, and their job is to see where the tumor is or where an abnormality is, and they trace it out. And they're very subtle that when I used to go and watch with my friend who was a major radiologist at our health system, he would say, you see that problem, we're really, and I'm saying, oh yeah, that's really bad, isn't it? And I would point at this big black blob. He would say, no, that's not it. That's the way it's supposed to be. And then he would say, here it is. And he would put his finger around something and I wouldn't even see it, even when he pointed at it. It was a very subtle shading. It's very difficult to see. But he spent hours and hours every day doing this, and he was really, really good. And I asked him, so now that the computers are as good as the average radiologist, and pretty soon they'll be better than even the best radiologist, what does that do to you? He says, oh, I'll be so thankful, because then I don't have to sit in front of these screens all day and never see the patients. I can go back to being a physician and actually work with the patients themselves. And a lot of that is going to be what happens. And right now, a friend of mine just did a study of AI in graphic design, designing logos for companies. It's nothing that the human factors community should care about, but it is a big use of graphic designers. So I see the Liverpool logo on Stephen's background.
Yeah.
And somebody designed it, and it probably took a long time and was paid a lot of money, and probably went through 18 different committees that said, no, do this, do that. Well, we have computers today that can do it just as well. Except they won't really understand what they're trying to do. They won't understand why you want to emphasize this over that, or what the importance is. So here's what the designer has to do. The designer has to specify the problem properly, state it properly, and then the computer will come out and generate all sorts of possibilities, and then you judge them and say, no, those are wrong. Do more like this, do less of that. And so in human factors, I can see the same thing as we put in some of the practical, put in the task that we're trying to do. And maybe there's a set of controls, we want to optimize the location of the controls and displays. That's a pretty standard thing that we teach our undergraduates to do. And you look at scan sequences for eye movements, and you look at the task sequence that is required, and you want to generate the optimum. And the problem is with many, many different controls and displays, it's not an easy task. Well, the computer could do that, except the computer isn't able to evaluate it, and isn't able to state the problem in the first place, and isn't able to evaluate really how effective it's going to be, or whether it's actually easy to build and construct. So what we do is we sit back and we watch, and we can use, it's actually, you're a better human factors specialist, because instead of trying to lay out things and then trying to see if it works, you're saying, no, that's not good. Or you say, wow, that's unusual. Yeah, that has potential. Do more like that. And then what you do is you can remodel, you can restate the goals and restate the constraints to force the computer program, the AI, if you will, to come out with things closer to what you're aiming at. In other words, I don't think AI is going to take away the interesting jobs. They will take away the very routine standard jobs, but it will cause us to become better human factors experts and human factors designers. And we will interact, and we'll have to do things in a different way, but in a way that's actually more pleasurable.
So what you're saying, I'm sorry. So what you're saying is we're going to be better at making decisions.
And characterizing the problem, better at making a decision, but also saying, you know, what the real goal is. I didn't give you the right goal. The goal is different. The goal is something else, or that the constraints that I gave are the wrong constraints. Let's rethink the problem about how we approach it. I have a case story. Again, it was in the design world, but Autodesk, which is an American company that has done a lot of this work in AI, they were trying to test out their equipment, and they found a great designer, and they said, would you please use this for a while? We want your opinion. And he said, I refuse. No, I'm a good designer. I don't need this ton of crap. And, but they finally forced him that, please use it, and we want you to use it for a whole month. And he said, okay, I'll do it. And so he did it, and he reported the first week, he said he hated it. And at the end of the month, he said, please don't take it away. I don't want to live without it anymore.
Mm-hmm.
Because he said he thought it improved his ability as a designer and also made his job more enjoyable. That when he finally decided on some structure, he didn't have to draw it 17 different times in different locations.
Mm-hmm. Yeah. Okay, thank you. Thank you, I appreciate it.
Thanks so much. I think we go to Portugal now, to Joana Vieira. Is that correct? Are you in Portugal?
Yeah.
Yeah, can you ask a question, please?
Yes. You published Changing Design Education for the 21st Century in 2020, so very recently. In the meantime, the 21st century has changed a lot. And my question is, would you change or add anything to the document after all the feedback you received since its publication, or after everything that happened since?
Here's what I'm doing. I've started a huge initiative. We call it the Future of Design Education. And so in fact, if you go to futureofdesigneducation.org, the website, you will see what we're doing. So we've organized a group of people that say, we want to change the way designers are educated. We want to make sure that designers have a broad education, not just in design. That we are changing from designers as craftspeople who make these beautiful objects and so on. Yeah, that's still important. Let designers do that. We love the beautiful objects, but we're not interested in that. We're going to do a different kind of design. We're going to do design as a way of thinking, of solving appropriate problems by getting to the focus on our people, getting to the core of the issues, not all the way down to the bottom, but to the lowest level where we can actually make a difference, but don't just solve the symptom. Recognizing that everything is a system, and so we have to know a lot about system thinking and how to treat them. And also recognizing that we're dealing with people and societal issues and cultures, and so we're never going to be right. So we have to always be testing and assuming that everything we do is provisional, and we do a lot of prototypes and tests and reviews and iteratively make things better. That's the fundamentals of the principles. And what we did was, first of all, it's sponsored by the UC San Diego Design Lab and IBM's design division, which now has 2,500 designers, including human factors people in that division, by the World Design Organization. We have a steering committee of approximately 20 very senior designers from all over the world. Half of them are practitioners and half of them are academics. And we have 700 volunteers who have offered to help us. And we are putting together a series of working groups to look at different components. For example, designers are never taught ethics. And they're never taught the notion of system design. And so where those are two important ones. And system design includes the concept of service design and well, the environmental impacts and sustainability, as well as all sorts of other issues. And so, and we want an education that will give people broad background, you know, and that can change over the years as the world changes, the problems change, and the technologies change. So we've already been at it for 1 year. We think it's be another 2 years before we probably have some reports. We've learned from other professions that have completely rethought the way they are taught. One of them was the business profession, and that was what got us started, how the business changed itself from executives who thought, oh, well, you know, I was successful, so I know how to do it. No, they were just lucky. And the newspaper industry and the legal industry, they've all changed their educational practices. The medical industry itself, the medical used to be, again, people who practiced medicine but didn't have any science behind it. And that got completely redone to today's medical schools, which is heavily science-based. And and computer science. In computer science, we decided was the best model because they have the same kind of problems we have. First of all, their field is taught in everything from a 2-year technical community college or polytechnic school to a major research university. And it's taught for people who are simply going to do practitioners and to people who are developing the advanced theories. And they have to do a wide variety of courses for these different kinds of people. And it's also many, many different disciplines, and the disciplines in computer science are changing rapidly. So they did this 20 years ago, and they took them 3 years to develop curricular recommendations. And every 10 years, they go back and they redo it. And even in between the 10 years, they actually come out with updates. So we talked to the person who was in charge of the second revision. They're now starting the third one. He's a professor at Stanford, and it was interesting because it took him 3 years. It was a big project. It's very similar to what we were trying to do. And I was trying to explain what we were about. And to my great surprise, he said, no, stop. I've read the design of everyday things, so I know what you're talking about. So that was pleasing. So that's what we're doing. We're trying to put the notion that we must change design for the 21st century into action. And when it comes to human factors, I'm not sure I would change the education, the content, because I think the way it's taught and the principles and the science behind it is, first of all, good, and second of all, it keeps up with the most recent discoveries and advances, and a lot of human factors people are researchers advancing the field. The weaknesses in human factors are what I talked about, the way it interacts with other fields, and the inability to actually provide the solution, not just the description of the problem. And I've often thought that human factors ought to be combined with some other areas to be more effective. So I might actually, well, maybe I'm wrong. Maybe I would change human factor instruction to give more advice, more instruction about design and understanding the constraints on design. And by the way, I've just finished a paper with a friend, the same friend actually who helped start this 21st century design effort. He's in the business school, but he was a senior executive at several design firms. And we said, design, the designing part is the fun part. And for you, I'll say finding the problems are kind of the fun part. That's what you're trained to do. But it's useless unless somebody does something about it. So it's the doing, designing or human factoring is fine, but we need doing, somebody who fixes the issues and somebody who builds the designs. And it turns out that's not so easy either, because most companies just can't do it. They're not organized in such a way that they understand these issues, and that you're going to ask them to change the way they do things. And so therefore you need to transform the company. Company has to understand the human factors and that design and that ability for people to use things, because my design is all about human factors, really. It's about making things understandable and usable. And that requires that the company understand that, so that you don't have division to say, I don't know what that's about, I'm not going to follow it. Or a middle manager who kills it. Middle management in companies is the hardest job, because these are often the bright people that are being promoted. But when you're in the middle, the people above you are telling you what you must do, and the people below you are pleading with you to let them do it the way they want to do, and you're sort of stuck. And oftentimes you're rewarded for the profitability of your division. And if you take a risk or do something differently, you're not rewarded for taking the risk. You're rewarded. In fact, I once had an executive explain to me when I was in charge of the research group at Apple. I said, most of our research projects fail. And the person said, yeah, I understand that. Why do you do them then? Well, we're doing risky things. But he said, that's great. but I only do the risks that succeed. I mean, why are you doing the ones that fail? And there's just no understanding that if we knew beforehand what was correct and what was incorrect, well, we wouldn't call it research, would we? So part of the problem that faces the good designers and the good human factors people, it's not them, it's that the environment in which we work doesn't understand and is not supportive. And so that's where the education is going to be needed.
Okay, thank you. Okay, Joanna, thank you. I'm going to move to another questioner now, one eye on the time. So Fabrizio, you've been waiting patiently. Hello, everyone.
You call
Somebody
my name?
has a mic. Somebody has to mute their microphone.
Hello, did you call my name, Fabrizio?
Now Stephen is muted.
Fabrizio, are you ready to ask your question now? Yes, please.
All right, thank you. It's a very pleasure. Thank you for this opportunity. My question is concerning what we are living at this moment. The current pandemic situation has brought to the surface the need for a step further in the person-centered approach to work and social interactions, in my opinion. It's not only a matter of usability or user experience for smart working. The issue is not how Zoom or Meets are well designed, but if and how they are designed and managed in order to respect our well-being. So do you think that we need a better fit between these tools and our emotional, cognitive, and social nature? Is the pandemic an opportunity to think about how technology can be a tool for working better and not just for working more?
Wow, yes. The answer to the question is yes. But if you take a look at the pandemic and the issues that are involved, they all have to do with human behavior. First of all, the pandemic should not have been a surprise. There are many people who have been predicting this. In fact, again, in the United States, there was a presidential commission that looked at the possibility of pandemics, explained how this is guaranteed to happen in the future. This was, say, 8 or 9 years ago, guaranteed to happen in the future, and moreover spelled out exactly how we should respond. But the problem is that people actually don't respond to statements of potential problems. We don't fix the infrastructure of our roads, of our telecommunication systems, of our pipelines, of anything. We wait until it breaks down and then we repair it. We spend a lot of money to build the stuff, but we don't give any money to keeping it maintained. And this is common across the world. And the same with the pandemic, because it was a hypothetical problem for the future, the advice was ignored. It also didn't help that we had an interim president who basically thought it was all nonsense and killed any effort to do the work. But again, that's people. So that's one problem. Second problem is that there is a fundamental conflict in the normal ways of fighting a pandemic. And it's a real conflict, and it's true. But one of them is that in order to prevent the spread of the disease, what we had to do was isolate ourselves, quarantine ourselves, keep away from other people, always wear a mask, wash our hands, because again, in the beginning, nobody knew what the real spreading vector was. And close all our businesses. So you have two evils. One of them is the pandemic, and the other one is economic loss and people losing their jobs. And I think, especially in the United States, we don't have the social systems behind us, so that when the company closes its doors because of the pandemic, the salaries disappear. And so lots of people refuse to follow the medical restrictions because they were so concerned about the economic implications. And I believe that concern is correct. But this is like all major problems. You have to do a trade-off. There's a balance about keeping the pandemic at bay, and there's and keeping the economics reasonable. And it's not easy to know where to place the line there. Finally, people objected. Many thought that what this COVID nonsense is nonsense. I think it's a myth. I think you're trying to delude us. I think it's a plot by the opposition party or by the ruling party or by whatever your favorite enemy is. And that it's a fake. And I don't know anybody who has COVID, and I don't know this. And why do we have to wear a mask? Ooh, that's horrible. I hate them. And today we now have a vaccine. And in the United States, something like 25% of the people refuse to take a vaccine. And I think that number is probably lower. I've seen other estimates of 50% of people refuse to take the vaccine. And it's often correlated with your political party. But the vaccine has nothing to do with politics, but whether you believe that the vaccine is helpful or is a plot against humanity does depend upon your politics. So, so the real issue is this: what have we learned from this that we can apply in the future? And I think the main thing we've learned is that the first and most important thing is not the medical requirements. The first and most important thing is that the people must have trust and faith in the spokespeople who are trying to explain what is going on. And it's the rare country where that has succeeded. It has succeeded in some countries, but there's many countries where there's complete distrust of the political administration. And therefore they don't want to believe what they're being told, what they're being asked to do. And remember that getting sick with COVID is truly serious. But not having a job and not having any income and starving, or even being kicked out of your apartment because you can't pay the rent, that's pretty serious too. And then the other problem is, even if you follow all these events and now, hey, the infections go down, then people say, hurrah, and they start going out again. And so guess what? The infections build up again. It's a very complex study of the intermix of good medicine, good principles, good understanding of the infections, and meeting, though, with distrust among the populace, and also just frustration of being, look, I have not traveled more than about 4 or 5 miles in the last year. That's, 10 kilometers in the last year. And I used to fly 200,000 kilometers a year. And I've been mostly staying at home, with exception of going outside periodically for exercise. And then I would do it early in the morning before the sun had even risen, so I wouldn't meet other people. And it is pretty restrictive. And so just normal human behavior is to say, the hell with it. I'm just going to go and I want to meet my friends. I want to go and have drinks with them. I want to talk to them. So the pandemic is a really good example. And I have a feeling there's going to be a lot of really interesting case stories and analyses that are going to come out in the next couple of years. What does it mean to the human factors profession? That I don't know. Your guess is as good as mine. But so much of that was it was the human part of the human factors profession.
Thank you so much. Yes, thank you. That's very relevant. An hour has passed already. Maybe to round off, Christopher, would you like to ask a brief question? Is that okay? Or am I?
Sure. Yes. Thank you. Can you hear me all right?
Yes.
Okay, great. I don't quite remember the exact question, what I wrote down a while ago, but I believe it was something to the effect of what would you say would be the biggest or most important challenge overcome in the last generation in the field? And on the horizon, upcoming, what would be posed as the next most important challenge to overcome for the industry?
Well, of course, we've covered some of that because a lot of the
Right.
challenge is not so much the industry, but how we are organized and the way we interact with the other kinds of disciplines. Because human factors itself doesn't build the equipment. Human factors doesn't create the rules. Human factors doesn't implement the things, but they ought to have a stronger role in that. Actually, one of the points I've been making to the design community, I'll make to the human factors community. How many human factors specialists are chief executive officers of large companies? How many human factor executives are chief technology officers or chief product officers or at the C-suite level? Very few. Actually, an interesting example is when I went to Apple, the person I was reporting to and who hired me was a good friend of mine, and his field was human factors. He had worked at NASA in aviation issues for many years before he left NASA and came to Apple. But that was rare that you had people executives who understood these issues. But Apple was also a unique company which actually understood trying to make things easy to use and understandable. So why aren't there more human factors people up there? And when I talk to designers about the same thing, I say, how much do you understand about business? No, I don't know. Well, if you don't understand about business, you're not going to get promoted. And in other words, in order to get up to that level, you have to step back from your field. And quite often, you may even recommend things that go against your field because you have to actually balance many different considerations and say, well, yes, there is a human factors problem here, but personally, it's not that serious. And there's another issue here that's more important. So we can only do one of them, so we should emphasize that other one. And when I was at Apple, and I found people like that who would step back and say, what's best for the person who's going to be using this equipment? And what's best for the company? And often they would therefore downplay their own work. That was the kind of person I would promote. There's someone who takes a look at the bigger picture, and you need training. And you also need to understand the principles of marketing, the principles of supply chain management, the principles of advertising, the principles of manufacturing, the principles of service, and of course, most important of all, the principles of finance. When you are trying to convince somebody that you have a great solution, how do you do it? I've had designers come to me and say, I can't convince my management. How do you do it? Well, I show them the wonderful work we're doing, and I show them the letters of appreciation we get, and I show them the prizes we win. And I say, okay, if I were the manager you came to, I would say, thank you very much. You do really good work, and we know that. That's why we hired you. So thank you very much, but excuse me, but now I have to get back to work. If you want to convince somebody of something, you have to understand the person. Just like when you design equipment or you study human factors, you have to study the people that are going to be using the equipment. And so you have to study the people that use your advice. And who is the people that use your advice? It's your boss or the boss of your boss or their management. And what are they rewarded for? They're rewarded for profitability or for increased sales or decreased costs. If you do a good job, that's not what they're rewarded for. That's what's expected. So what you have to be able to do is say, if you follow my principles here, and I show them a Excel spreadsheet, see, increased profits, see, decreased costs. Now, the answer I usually get from people is, well, how do we do that? I mean, it's true that if you follow human factors, better principles, we would have less maintenance problems. And we would have less accidents where we have to send in specialists and, for that matter, sometimes spend a lot of money on lawyers and lawsuits or paying for, accident compensation. there'd be a big benefit. But how do you convince them? You convince them by showing them the spreadsheet. But where do the numbers come from? And the answer is you make them up. Marketing does this all the time. Engineers do all the. How do they get their stuff in? They go and they show the spreadsheet. Now, look, management is not stupid. They know you made up the numbers because that's what they did when they were moving up in the organization. But it's not because you're lying. It's because there's no other way. When you're trying to make a change and trying to guess the potential outcome of that change, you have to make up the numbers. So what management does is they look at them and they ask themselves, are the assumptions sensible? Does this really make sense? And if so, they might say, yeah, that's something worthwhile. That's the kind of thing that management has to decide all the time. They have to judge and with incomplete and ambiguous data. But you have to provide it for them in a way that they understand. And showing them pictures and showing them data and showing them letters and so on, that isn't what's going to help them make a decision like this. So that's a very important thing for the future that I think has to change. What else? Well, another factor with human factors, especially as the technology changes, there was a major change when electronics became there. Nowadays, it's worse because it's all computer controlled and wireless, and it's very difficult. You can't see anything. And you don't know where the problem is. And on top of that, it used to be when you made mechanical equipment, you had to have a big lever or a wheel or something that would move the mechanical equipment. And so people could kind of figure it out how it was working. But when it's all computer controlled, it's up to the arbitrary whims of the programmer or designer. And so we therefore have to get into the head of the programmer or designer. And that's up, like an earlier question. They need to understand human factors. And there are two ways of doing it. One is they get trained in it, or second is, well, think about how we develop things today. It's never done by a single person. It's done by teams. And the teams are multidisciplinary. I mean, even if you look in the programming world, the specialties in programming are so different that one person can't program at all. I do drivers. I do operating systems. I do the human interface. I do communication. They don't understand the other people's work, but they have to learn to communicate, to work with each other. Well, there ought to be a human factors expert in there. Why aren't human factors experts in the software design team? And for that matter, in the hardware design team. I visited a factory in Italy, in Modena, that packaged medical pills. And it was they had this huge machine that they sell. It's a couple €100,000 for the machine. But the way it worked is you dump in thousands and thousands of pills there. You give it a big roll of plastic here. You give it a big roll of cardboard here. And out the other end come these cardboard boxes filled with just the right number of pills and printed and labeled and everything. And it was just really impressive. And they came out so fast. They had great big bins in which they collected the filled pill boxes, and they kept filling up rapidly. They had to keep switching the bins. And so I looked inside the device, and it had all sorts of controls and all sorts of settings and all sorts of things you had to do. And I talked to the software people who had designed the software, and we talked about how they designed it. And I talked to the hardware people who had designed all of the controls. And it struck me that there was an incompatibility there. So I asked the two of them how they worked with each other. And the answer is no. We're the human factor people. We only work in the mechanical part. Now, we're the programming people and the HCI people. We only work on the software part. And as a result, the system was far more complex than it had to be, I am convinced. And it turned out I was right in the sense that when they decide they have to switch the boxes and the pill configuration and so on, how long does it take you to set up the this machine to do that, it can take a whole day. And I didn't ask about how many errors get made in setting it up, but I bet you there's a lot. So we need to work in teams with different disciplines and to share our expertise. I mean, might very well, if we're doing the mechanical thing, say, we think this would be better done by the software. And if we're doing the software, we might very well say, this really requires a physical switch or physical control. But it has to be done as a team, collaborative, cooperating. So that's what I would say is going to happen in the future.
Thanks very much. Thanks very much. I think I should hand over to Antonella now to conclude the session. You're still on mute, Antonella.
You're muted.
This is a standard phrase.
You still are muted. No, you are still mute. Ah, yes.
Okay, great. I didn't find. Okay, so the time is running very fast, too fast. We would like to thank you very much, Don, Stephen, Dick, and you all for the nice and fruitful discussion that gave us interesting contents and hints which will inspire our next studies and activities. We would have liked to talk even more with Professor Don Norman, but who knows, maybe there will be other chances. For instance, maybe in next time we will have other possibilities. For instance, we are organizing some other online events in autumn 2021. The idea was to involve keynote speakers of our previous annual conferences to deepen with them how their research evolved in 2, 3, some years after their first speech at our meetings. So stay tuned and check out our website for the autumn events announcement. And so thank you, Don, once more for your kind availability in sharing with us your experiences. We really, really appreciate it. And please stay safe and healthy. And we are looking to meeting you all again very soon. So this is our hope.
Thank you very much. I very much enjoyed this interaction, and I hope that the audience did as well.
Thank you very much. Take care. Bye. Thank you all.
Bye-bye.
Ciao. Bye.